Cambridge International ASN A-Levels Physics Paper 1 Multiple Choice October-November 2025 Paper 11. So here's a list of all the data that you might require. We have acceleration, we have speed of light, we have elementary charge and a bunch of other values. Then we have some formulas that we're going to use: the acceleration formula, pressure formula, upthrust formula, Doppler effect formula, electric current resistors. Sometimes we forget the formulas, so don't forget that you have a sheet in the beginning which you can use. So let's get started. The table shows some physical quantities. Which row identifies the quantities as scalars or vectors? Acceleration is the rate of change of velocity, and we know that velocity is a vector quantity, so that means acceleration is also going to be vector. Charge is basically current. Q equals to IT, so charge is current into time, and we know that charge is a scalar quantity because charge has no direction. Then we have kinetic energy. We know that all types of energies are scalar quantities. Energies are never vectors, they're scalars. Then we have wavelength. We know wavelength is basically the length, and length is a scalar quantity. So this is the correct answer. Two quantities are measured. First is, I guess, the length, and second is the time. L and T are related to x by the equation shown. Okay, what is the calculated value of the uncertainty of x? So now we have to calculate the uncertainty in x. First, we are going to calculate the value of x. X equals to 4 multiplied by pi square multiplied by the length is 6.8 centimeter. We are going to keep it in centimeter because the answer is also in centimeter. So 6.8 divided by time square. Time is 2.42, and we square it. We put all this value into the calculator and let's see what we get. 4 into pi square into 6.8 upon 2.42 square. We get 45.83929371 centimeter per second square. Okay, now what is the calculated value of the uncertainty? I also need to calculate my uncertainty in my value. How do I calculate the uncertainty in x? I know that my value of my uncertainty in x upon my value of x into 100% is going to give me the percentage uncertainty in the value of x. And how do I get the percentage uncertainty? It is going to be the percentage uncertainty in L plus the percentage uncertainty in T. How do I get it? It's going to be, for L first, let's find out. It's 0.1 upon the value of L, which is 6.8 multiplied by 100. Plus, we calculate for T. For T, because there is a small square on T, so we're going to multiply the percentage uncertainty with 2. 2 multiplied by 0.08, 0.08 upon 2.42, 2.42 times 100. We add their percentage uncertainties. 0.1 upon 6.8 into 100. I'm doing this on my calculator. 2 into 0.08 upon 2.42 into 100, and I get 8.082% as my percentage uncertainty in the value of x. Now I have the percentage uncertainty. So the percentage uncertainty is going to come out to be 8.082. And instead of my actual value of x, I know it's going to be 45.8. So instead of my actual value, I put 45.8. Now I solve for delta x. Delta x equals to 8.082 multiplied by 45.8 upon 100. Delta x comes out to be multiplied by 45.8 divided by 100. it comes out to be 3.7. Now I know that my percentage uncertainty is always written to one significant figure. Don't forget this. And my uncertainty is also always written to one significant figure. So I'm going to round 3.7, which comes out to be 4. So my percentage uncertainty is going to be 4, and my value of the thing, that is this x, is also written to the number of significant figures, to the number of decimal places of the percentage uncertainty. Now percentage uncertainty is up to 0 decimal places. Like there's no decimal in my percentage, not my percentage, my actual uncertainty. There's no decimal in it. So there has to be no decimal in my value as well. So it's option D. Over here you can see there's one decimal in the actual uncertainty. So there's going to be one decimal in the value. If there's one decimal here, there's going to be one decimal here. If there's no decimal here, then there's going to be no decimal here. That's a very important thing, that your value has the decimal places equal to the value of your uncertainty. What are the SI base units of watt? So watt is the unit of power. So watt equals to your work done upon time. Work done equals to joules upon seconds. Now joules equal to force into distance upon second. Force equals to kilogram meters per second square multiplied by distance is in meters upon seconds. Kilogram meter square per second square multiplied by second -1, because this comes here, it becomes second -1. Kilogram meter square second -3 is the SI units of base units of watt. Kilogram meter square second -3. Okay. The diagram shows two forces of 6 newtons acting on an object. So one force, this one has two components. This force, there's going to be definitely a vertical component and a horizontal component of this force. The angle between the lines of the two forces is 60 degrees. What is the magnitude of the resultant force? To calculate the magnitude of the resultant force, first you need to realize this vertical component of this force is 6 sine 60 and the horizontal component is 6 cos 60. You resolve the two forces, 6 sine 60. So now if I resolve it in the vertical components, I have 6 sine 60 over here. Let me find the proper value for 6 sine 60. And in this direction, I have two forces. One is 6 Newton and the other is plus 6 cos 60. So 6 newtons plus 6 cos 60 newtons. So now I'm again gonna draw it with proper forces labeled. 6 sine 60, what is the value coming out to be? 6 sine 60. It gives me 5.196, and this value, which is 6 plus 6 cos 60, 6 plus 6 cos 60, this gives me 9. So now I have to find the resultant of 9 and 5.196. If I arrange it in the head to tail method, I know that this force is like this, 9 newtons, and now from the head of this I draw the other force, which is 5.196, and the resultant is gonna be from the tail of my first vector to the head of my second vector. I use the Pythagoras theorem to calculate the hypotenuse, which is gonna be 9 square plus 5.196 square. So you calculate the hypotenuse, which is 9 square plus 5.196 square, and that comes out to be 10.39. equals to 10.39 newtons. The resultant and the direction of the resultant is going to be something like this, which makes this the correct option if we round it off. A goods train passes through a station at a constant speed of this at time equals to 0. Okay, so now goods train has a constant speed. When we have a constant speed, we have zero acceleration. And when we have zero acceleration, we can only use one motion formula, that is distance equals to speed into time. So distance, I don't know, speed they're telling it's 10, and the time, I don't know right now what is going to be for the complete journey. An express train is at rest at the station, so that means rest in, we in physics we just ignore the word acha rest likha hai, theek hai. But it's not there to ignore. Rest means that the initial speed of the object is gonna be 0. Never ignore rest. The express train leaves the station with a uniform acceleration of 0.5 meters per second square. So that's the acceleration that's uniform. Just as the good train goes past, both trains move in the same direction on a straight parallel tracks. At which time t does the express train overtake the goods train? Okay, so over here you need to find one thing. You need to find the time that's going to be equal. Time is going to be equal at which your goods train, this is your goods train GT, and this is your express train ET. Okay, so now your goods train is basically moving, and it is gonna, at a certain time, it's gonna bypass your ET, right, the express train. But as the goods train and express train are moving, at some point, express train is gonna overpass the goods train, right? Okay, so no worries. Express train is over here, it's gonna overpass the goods train. But at a certain point, what's gonna happen is that before overtaking, express train has to come equal to the goods train, right? When express train is gonna come equal to the goods train, two things of express train and trains are gonna be equal. What are those two things? Firstly, the distance they're gonna travel is gonna be equal. The distance and the time at which they're gonna overtake is gonna be equal. So I know two things equal, distance and time, and I need to find one of them, time. So I know that I can make an equation of distance in which there is time for both equations, because I know distance and time are equal, and I can only equate the time of the goods train with the time of the express train if I have equal distances. So over here I know distance equals to speed into time. I don't know the time which I need to find. I have two unknowns, D and T. Now I need another equation which I'm going to make for the express train, in which D and T are going to be unknown. And then by using simultaneous equation, I can solve them. So the other equation for my express train is going to be S, which is the distance, equals to UT plus half AT square. Up in which I can write S as T, distance, which is displacement, I know, but I don't know it, equals to U. I told you U is 0 because it is at rest. UT is going to become 0. So that's 0 plus half times A. What is A? A is 0.5 times, it's written A 0.5 times T ka square. So now what do I get? I get two equations which I need to solve simultaneously. The first equation is equals to D equals to 10 into T, and the second equation is D equals to half into 0.5 into T square. These two distances are going to be equal when they're going to overtake each other. So can I equate the two equations to find the time? Yes, I can. 10 into T equals to half into 0.5 into T square. So 20t equals to 0.5t square, and if you try to solve it, what's gonna happen is that 20 upon 0.5 equals to t square upon t gets cancelled with the square. 20 upon 0.5 equals to t, 40 equals to t. So that means our answer is going to be 40. I hope you understood what I did. Always remember, when you have two equations, you need to find out something that's constant between the two equations. And over here we got two things that were constant, the time and the distance. And then what we did, we created two equations which had time and distance, and then we simultaneously solved them by the method of substitution by equating both. A ball is held above the ground and released. The ball falls to the ground and bounces several times. The graph shows the variation of the time with the velocity of the ball. So what is happening is at this point, which is P, you drop the ball, okay? You need to understand the graph in terms of the ball. So at this point, this is P, okay? You drop the ball. Over here, the velocity is 0, time is 0. Now what happens? The ball, as you dropped it, it's going to accelerate downwards. That is why there's a constant gradient, and it's going to accelerate at 9.81 meters per second square if we are dealing with this ball on the surface of Earth. Going to accelerate, going to reach its maximum velocity at Q. At Q, it's going to hit the ground. So at Q, we're expecting the ball to be at this position, and then it's going to bounce back upwards. There is a change in the direction of velocity because our direction of the displacement has changed. Now it's going to displace upwards from its now it's going to displace upwards towards its initial position, which was P. So now it's going to move upwards like this, and it's going to keep on accelerating upwards unless at S it again changes direction, displaces downwards, and the system continues until the velocity of the ball is going to be so much reduced that it becomes 0, because we know that this is inelastic collision, because we can see a constant decrease in velocity. That means the energy is not conserved. Not all the GP is converting into the kinetic energy of the ball, because the increase in the velocity, you can see the peaks are reducing. In the first bounce, it reached a maximum of Q velocity. In the second, it reached a maximum of S velocity, which is lower than Q. And in the third, it reached this, which is even lower. The area under the line PQ, so they're telling about this area, this area. I wish I could make it clearly. Represents the initial height of the ball. Yeah, that's correct. It represents the initial, because what did I tell you? PQ, P till Q, this area. So this basically represents the displacement from P to Q. And what did I tell you? From P to Q, at P it is at this position. At Q it has touched the ground. So from P to Q, the displacement is basically the height of the ball above the ground. You can see it for yourself. So this is correct. Which statement is not correct? The collision between the ball and the ground are inelastic. 100% true, because the velocity is decreasing. The gradient of the line RS represents the acceleration due to free fall. That is correct, because there's no force on the ball. You're not applying any force. You just dropped it. So this line gradient is representing the acceleration due to free fall. Check the gradient. All gradients are equal. This gradient, this gradient, this gradient, all the gradients are telling the acceleration of free fall, because the ball is just falling under gravity. There's no force on it. We're not even including air resistance over here. You know why? Because the distance must be so small that air resistance effect on the ball is negligible. So this is also correct. The maximum upward velocity of the ball is reached at point P. Oh my god. Look. At point P, there's no maximum upward velocity. At point P, the velocity is 0. The maximum upward velocity is gonna be, look, at point Q, it touches the ground, and then at R, it's going to have the maximum upward velocity, I think. So that's the point. Q is incorrect. Okay? Option D is incorrect, that at P it has maximum upward velocity. An object is projected horizontally. The vertical distance y and travels a horizontal distance x before landing onto the ground. So this is y and this is x. A second object is projected horizontally with the same initial velocity and falls a vertical distance 4y before landing onto the ground. So now they're saying that we're increasing y to 4y. Before landing, assume air resistance is still negligible. What is the horizontal distance the object is going to travel? So what's going to happen to x if we increase y to 4y? Okay, remember one thing, that in projectile motion, the vertical distance and the horizontal distance are two separate things. They're two completely separate things. You say that the object falls like this, but there is no equation that's going to make you deal with vertical and horizontal distance like in the same essence. They're two different things. We deal them differently. We use different equations for each one of them. So you cannot use think that okay, it's fine if it's going 4y, it's going to go happen 4x. No, there's no relation like this. You have to find a common ground between the vertical distance and the horizontal distance, and then with that common ground you have to look at the relation of both equations. What do I mean? Let me show you. So my vertical distance, if I use the equation s equals to ut plus half at square for it, first things first, you should remember that time is the only thing that's same for both vertical and horizontal distances, because the time in which the object is going to travel this vertical distance, in the same time it's going to travel this horizontal distance, and it's going to reach at this point. So in equal amounts of time it travels this and this distance. So the only thing common between the two distances is time. So first I'm going to figure out the relation of the vertical distance, which is s, with time, and then I'm going to figure out the relation of my horizontal distance with time, and then I'm going to equate the two. So s equals to u, initial speed we're considering to be 0, t, this is going to become 0 plus half at square. This becomes equals to s equals to half at square. Acceleration over here is constant. Constant acceleration means that we can make a relationship between s and t square. When the third quantity is constant, you can determine a relationship between this and this quantity. So s, which is the vertical distance, is directly proportional to the square of time. So now you know that s, which is the vertical distance, is becoming 4y. So 4y equals to time ka square under root 4y under root time cross 2 equals to time. That means with time the vertical distance is doubling. Okay, so it's becoming 2. Now determine the relationship of time with the horizontal distance. How do you determine the relationship of time with the horizontal distance? Speed equals to distance upon time. Distance equals to speed into time. Speed is constant because horizontal speed never changes. If this is constant, we can say distance, which is your x distance, is directly proportional to your time. We saw time over here doubled, so it became 2t. Since time doubled, x I said directly proportional hai, to hamara jo horizontal distance hai, it's also going to double. It's going to become 2x. That's why this option is correct. I hope you understood. What we did was we found a common ground between the horizontal and vertical distances, and then we equated them by using the relationship with time, because time was the only thing that was constant between the two. Okay? Time was the only thing that was constant between the two. A sphere falls vertically from rest through air. Through air means that air resistance is going to be considered. The graph shows the variation with time of the sphere's velocity. So the velocity is initial gradient is going to be 9.81. Since air resistance is going to then act, because the velocity is going to increase, then the gradient is going to decrease because the resultant force is going to be decreasing. And then initially the gradient becomes 0 because the acceleration of the object is going to become 0. Okay, done ho gaya. Which diagram shows the forces acting on the sphere when it is at the velocity corresponding to point P on the graph? When it is at the velocity that's corresponding to point P. Now listen, what's happening at point P? We can see this. This means that firstly, velocity time graph gradient tells you about the acceleration. Gradient is like this. That means it is accelerating. That means that the forces are unbalanced. They are not equal. And since it's accelerating downwards, the downward weight should be greater than the air resistance. Got it? You know that at this point, when it is flat, the weight and the air resistance become equal, right? They become equal. That is why the forces become balanced. The resultant force becomes 0. The object stops accelerating. It moves with the constant velocity, and that constant velocity comes from this point on the graph. But at this point, it is still accelerating, though the acceleration is decreasing. I know it's decreasing because the air resistance is increasing, but still it's accelerating because the gradient is not constant. That's why weight is going to be greater than air resistance. This point, weight and air resistance equal, is going to happen when the line is flat. Only weight acting and no air resistance acting, it's going to be just at the beginning of the graph. Okay, just when it begins to fall, at this point only weight is going to act, no air resistance, but for a very short period. At this, when the air resistance is less and the weight is more, it's going to be at this point when it begins to accelerate, but the magnitude of acceleration is decreasing because the air resistance is increasing. Achha. When the air resistance is greater than the weight, it's definitely going to happen when you're going to open the parachute, and then it's going to like fall like this. अभी इस ग्राफ पे कोई भी ऐसा पॉइंट नहीं है जहाँ पे air resistance is greater than your weight. Okay, so now this says, in which situation is the total linear momentum always conserved? In all collisions between two objects. In collisions between two objects moving at equal and opposite velocity, ये तो completely incorrect है ना? Because even though they don't have equal masses and velocity and whatever, the momentum is like always conserved. In collisions between two objects that form an isolated system, that is correct. Because what is the conservation of momentum we have studied? That for an isolated system in which no external forces from outside act on the system, the momentum remains conserved. So it's going to be option C. In the collision between two objects with the same mass, no. Even you've solved like a bunch of questions in which the masses are not equal in all collisions between two objects. In all collisions, in only collisions in which no external forces are acting. If there's a collision and some random forces act from outside, the momentum is not going to remain conserved. Okay, so now we have this question. An object of mass m, so mass of the object is m, moving with a velocity of 9 meters per second, has a heads-on elastic collision with a stationary object of mass 2m. Let's draw out the scenario. What's happening is that we have this object that has a mass of m, and let's assume it's moving in this direction with a velocity of 9 meters per second, and it has a heads-on elastic collision with another object. And just for the sake of goodness, we're going to consider that this object has a mass of 2m and it has a velocity of 0 meters per second. After the collision, both objects are moving. No external forces act on the system. Do you see this? No external forces. That means we're dealing with an isolated system. Okay. What is the velocity of the object of mass 2m after the collision? Okay, G. So to figure out the velocity of this object after the collision, we know that since we are having an elastic collision, there are two things that are going to be conserved: the momentum and the kinetic energy. By using the conservation of momentum, I've created this first equation. As you guys can see, that the momentum of this ball before collision and this ball before collision was 9m, and the momentum of the two balls after collision is going to be mv1 times 2m, because the mass is 2m, times v2. So I've created this equation 1 just by simplifying simply. Now I'm going to create another equation by using the law of relative speed of approach and separation is going to be equal for the balls in an elastic collision. Since we're dealing with elastic collision, so the relative speed of approach and separation are both going to be equal. Achha, first I talk about the relative speed of approach of the two balls, which is going to be u1 minus u2 equals to v2 minus v1. Ab now u1 over here was 9 minus u2 was 0, since the second ball was not moving, and v2 minus v1, I don't know both of them. 9 equals to v2 minus v1. अब ये equations आप लोग को बनानी पड़ेंगी. अब I have this. What I need to find is my v2. You can see over here, I need to find the velocity of the object after the collision, the velocity of the 2m mass object. So what do? Velocity of the mass with the object 2m, I use this equation and plug it into this equation. So I make v1 the subject over here. v1 equals to v2 minus 9. ये बन गया. अब v1 को इधर जाके प्लग करें. 9 equals to v2 minus 9 plus 2 v2. ये बन जाएगा 9 उधर जाके प्लस हो जाएगा. 9 plus 9 equals to 3v2. 9 plus 9 होता है 18 equals to 3v2. 18 होता है 3 6 times, so 6 equals to v2. ठीक है, ये आप लोग का आंसर आ गया. I hope you understand how I did this. I simply first used the rule of conservation of momentum in an elastic collision, according to which my momentum had to be conserved over here. So I made this equation out of my conservation of momentum, and the second equation with the red that I made is because of my relative speed of approach of the two bodies equal to the relative speed of separation of the two bodies. That's the universal equation. u1 minus u2 equals to v2 minus v1. Okay, so that is the equation that you have to use. So my answer is coming out to be 6 meters per second. So it's going to be option number D. The graph shows the momentum of a motorcycle changes with time. So we know that the change in momentum we can get from the graph, and we know the time. So we know that the gradient of this graph is going to give me the resultant force. What is the resultant force on the motorcycle? So you know that resultant force, which is force net, equals to your change in momentum upon your time. The momentum is changing 5,000. You can see it, kilogram per meter second, upon the time, which is 10 seconds. Cut, we get 500 newtons as our resultant force. Easy. A rocket has a weight of W and initial acceleration of A. As the rocket leaves the ground vertically, the acceleration of free fall is g. Which expression gives the initial upward force exerted on the rocket due to the engine? So over here, the rocket is accelerating. So we know that whatever that force is, this is a rocket. The first thing is we know there is a weight of a rocket and there is an upward force of the rocket. Let me call it U. And U and W are not equal. Why are they not equal? Because the rocket is accelerating, and since it's accelerating upwards, we know that U has to be greater than W. So I know that U minus W, which is gonna give me the resultant force, equals to MA. Now I know that in my answer is there is no M. So for M, I simply can write another expression, which is U minus W. What is mass? Mass is your weight divided by your gravity times A. Now this, I need to find this upward force. So this W is being added here. On the other side, it's going to be subtracted. So U equals to W upon G A plus W. That is the expression I get for my U force. You can see it for yourself. That's simple. That your net force, after subtracting upward and downward forces, you get your resultant force. You get your resultant force, and resultant force equals to MA. We wrote M like W upon G, and that is the correct expression for M. अगर आप देखो W equals to mg होता है, तो M हो जाता है W upon G times A, and then you move it to the other side and you get plus W. So ये हमारा बन रहा है ये वाला expression. Good हो क्या? A uniform rod of weight 28 Newton is supported at one end by force F. Okay, so the rod is supported on one end by force F like this. The rod is in equilibrium and attached to a frictionless hinge at end X. So rod is attached here, and then I know there's a weight and I have to find the magnitude of F. Now I know that my clockwise momentum, whatever it is going to be equal to my anti clockwise momentum. So over here, I can figure out two things. One thing is that this weight is going to have two components. This component, this angle is also going to be 40, because you know that अगर हम देखें right angle triangle है तो ये भी 40 आता है. अच्छा, अब now we know this is going to be 28 cos 40 component, and this component right here which goes straight is going to be 28 sin 40. Now अब ये जो 28 sin 40 component है, it is passing through the pivot, so it's going to have zero momentum. So now the two two moments I'm going to consider is my this moment and my this moment. These are the two moments I'm going to consider. Now I know that my this length, I don't know. But if I consider this length to be L is my this length, then this length for this force is going to be half L. So I know that my half length times my force, distance into force, which is 28 cos 40, 28 cos 40 equals to my full length multiplied by force F. Okay, this is this moment in this direction is my clockwise moment, and this F direction moment is my anti-clockwise moment. Good, we equated the two moments. We considered this length to be L, this length to be half L. L gets cancelled with L. To 28 cos 40 divided by 2 equals to F. Do it on your calculators. 28 cos 40 divided by 2. This gives me 10.724 newtons, which I round off and I get 11 newtons. Got it? This was easy. Okay, two forces each of magnitude F act in opposite directions on a rod. So now we have two forces acting in opposite directions on a rod. Each force acts on the rod at a distance d from the pivot P. What is the torque of this couple about P? You know how do we calculate torque of a couple. We take 1 times force and the distance between the two forces, right? Force into distance between the two forces. Now we know force is F times the distance is 2d between the two forces. They're d plus d, which is going to give me 2d. Force into 2d, it gives 2fd. Where's 2fd written? 2fd this. Got it? A man of weight 600 newtons stands with both feet flat on the ground. What is the reasonable estimate of the pressure exerted on the ground by the weight of the man? So pressure equals to force upon area. Firstly, I don't know the area of the feet of the man. So what I'm going to do is that I'm going to draw a foot like this, and then if we just think about it, I guess the length should be about half that of a ruler, so it's 15 centimeter, and the width is about 5 centimeter. I'm just estimating. So if I calculate the area, it's going to be 15 को अगर meters में लिखना है, 15 into 10 raised to power negative 2 times 5 into 10 raised to power negative 2. How much area do I get? I'm just estimating it. So my estimated area comes out to be 7.5 into 10 raised to power negative 3. So that's for 1 foot, and my man is gonna have 2 foot, right? What is the reason for the pressure exerted by the weight of the man? So I multiply this area by 2 times 2. I get 0.015 meters square. Done हो गया. Force, I know it's 600, that's the weight, 0.015 meters square. 600 divided by answer, and that gives me 4 1 2 3 4 1 2 3 4 4 into 10 raised to power 4 pascals. Am I correct? 4 into 10 raised to power 4. So option C. Got it? I just looked at 10 raised to power. Okay. The formula for the upthrust on a block of wood is partially submerged in water is shown. What are the symbols rho and V represent? So basically, this is your water and this is your block of wood. Okay? This much block is submerged in water and the above part is not. So this rho basically tells you the density of water, V tells you the volume of the block that is submerged, and G tells you the gravitational field strength, which is 9.81. So rho is your density of water. V is the volume of the whole block. No, the volume of the block below the surface that's submerged. So that's the formula for upthrust. You should learn what each thing represents in the formula. An object with a mass 100 grams falls vertically a distance of 10 meter. What is the change in the GPE of the object? So change in GPE equals to mgh. Mass is in grams. We converted into kilograms. How do we convert it? Divided by 1000 times g, which is 9.81. Height, which is 10. Cut it. 9.81. Still, I think I should do it on a calculator. I should not just risk. I know I'm right, but like, why risk it? Yeah, we get 10 joules as our answer if we round off 9.81. Okay. A bungee jumper jumps from a platform and is decelerated by an elastic bungee cord as shown. So what's going to happen is this man is going to jump off from here, and then there's going to be some changes in energy. The GPE is going to convert into KE and then further change. Okay, when the jumper makes the jump, his initial GPE relative to the ground is converted into the kinetic energy and into the elastic potential energy in the cord. So obviously you know that when the cord is going to extend after some point, it's going to gain EP whatever elastic potential energy. At which part of the jump are all three types of energy non-zero? On the platform before the jump. Obviously on the platform before the jump, your kinetic energy is zero because the man is not moving. So cross. On the way down before the cord has started to extend, if the cord is not extended, then his elastic potential energy is zero. On the way down as he decelerates, that is correct because when he is decelerating, he's moving, so he has kinetic energy. He's moving downward, so he is losing GP, yes, some GP, because he's above the ground. And then because he's decelerating, because the cord is extending, so he has elastic potential energy. At the bottom of the jump, when he's stationary, he has no kinetic energy. That is why at C, he has all three values of energy that are non-zero. A sailboat is pushed by the wind at a constant velocity v across the lake. Okay, so I have this lake in which I have water, and then I have a boat in it. Good ho gaya. It is moving with a constant velocity v, constant hai. The force of the wind and the velocity of the sailboat are in the same direction. So now it is moving because wind is applying a force, that's F on it. Which additional information is required to determine the work done per unit time? What is work done per unit time? Power equals to work done per unit time. So you're looking for the power, and power equals to force into velocity. So the work done per unit time equals to force into velocity. Remember this, in the velocity is constant. Which additional, the force exerted by the wind, that is what you need, because force into velocity is going to give you the power. Got it? The weight of the sailboat, it's moving because of the force, so you need the force. A spring is fixed at one end. The length of the spring is increased by applying a tensile force F to the other end. The graph shows the variation of L with F. So this is our spring. We have a fixed length, which is L, and then it's going to increase, and then we are applying a force to it. Simple. What is the elastic potential energy of the spring F when the force of the spring when the force is 6 Newton? So we know that elastic potential energy equals to half into extension into force. Force is 6 Newton, extension is this. Remember, don't take the entire length. This L is the entire length of the spring. You only have to take the extension. Extension is gonna be 12 minus 8 equals to 4 centimeter. Convert it to meters because centimeter is not gonna do your work. So it's 4 into 10 raised to power negative 2 times half. Let's see, what do we get? Equals to 0.12 joules. Option number A. A wire has an unstretched length of 2. L equals to this. The stress is this. And the new length of the wire is this. The wire obey Hooke's law. Find the Young modulus. Young modulus equals to stress upon strain. We have the value of stress. For strain, we have to calculate strain equals to the change in length, which is coming out to be this minus this. The change in length is going to come out to be 0.10 upon the original length, which is 2. Let's see what do we get for the stress, for the strain. 0.1 divided by 2. 0.05 meters. So stress is 1.6 into 10 raised to power 5 upon strain, which is 0.05. The Young modulus is going to come out to be 1.6 into 10 raised to power 5 divided by 0.05. Young modulus is coming out to be 3.2 into 10 raised to power 6 pascals. What is the SI base unit of stress? Okay, no worries. Stress equals to force upon area. Force equals to mass into acceleration. Area equals to meter square or length square. Mass equals to kilogram meter per second square upon meter square. Kilogram meter per second square times meter negative 2 gives kilogram meter negative 1 second negative 2. Okay, solved it in front of you. Easy. The diagram shows a force extension graph for a rubber band as the band is extended and then stretching force is decreased. So now we know that this is when we stretch band. So please don't forget this. This entire area is the work done to stretch the band. And then you bring the band to the original position. So now this entire area under this line is the work that is recovered when you stretch the band. When you bring it to original position, this blue area work is the work you get back. Okay, and then there is a work that you don't get back. This green area that I'm highlighting is the work that is lost as thermal energy that you don't get back. Okay, so total work done on the band is green area plus blue area. The energy that's recovered is the blue one and the energy that's lost is the green one. ठीक है, समझ आई मेरी बात? अब इसको भूलना नहीं. अच्छा जी. What can be deduced from the graph? The rubber band does not return to its original length when the force is decreased to 0. It does. Look, it is first increasing and then it decreases back to 0. It is returning to its original position, right? The rubber band obeys Hooke's law for the extension shown. Does it obey Hooke's law? No. Hooke's law means a straight line like this. I am sure you can see the curvature. You can see a curve over here. So cross. The rubber band remains elastic for the extension shown. Yeah, that's correct. Elastic means it's going to return to its original position. Inelastic means it's not going to return to its original position. But elastic means it's going to return. So this is elastic. So option C is correct. The shaded area represents the work done in extending the rubber band. No. This entire area is the work done in extending the rubber band. Entire area under the graph. The shaded area represents the work that is not recovered, that is lost as thermal energy or whatever form of energy. Which row is correct for sound waves? Can travel in vacuum? No. Sound needs medium to travel because sound propagates by means of rarefactions and compressions. And compressions and rarefactions need a medium to be formed. So, can travel in vacuum? No, it cannot. Can be polarized? No, electromagnetic transverse waves can only be polarized. Can diffract through a gap? Yes, sound waves can diffract. So, A. Because it show waves like property, so it can diffract, like it can bend like this. That's why you can hear like from a door that's like partially open because there's some gap from with the sound diffracts and stuff like that. A source emits progressive sound waves in a horizontal direction. The wave travels away from the source in the direction towards the right. Okay, the wave travels away from the source in the direction towards the right. So this is my speaker, for instance, that is emitting sound waves. They're going to be compressions and they're going to be rarefactions. Okay. The graph shows the variation of the displacement of the particles from the equilibrium position. So that's the mean position of the particles. Over here, particles have displaced to the right of there. With the distance from the source particular instant, the displacements to the right of the equilibrium positions are shown as positive. So basically, the particles over here, I'm telling you, they've displaced to the right. So they're moving this way. They're moving away from the equilibrium position. And the particles that are towards the left, these particles are basically moving in this direction, thiswards from the equilibrium position. So over here you are being shown a rarefaction. I think it's a rarefaction. Particles are moving away from the equilibrium position. अच्छा. Position y represents the displacement of the particles. अब यहाँ पे देखो ये y पे जो particle है ये left की तरफ move कर रहा है. हमारी source हमारी left की तरफ है, ठीक है. मैंने आपको बताया नीचे की displacement का मतलब है कि particles are moving towards the left and your source is towards the left. Position y represents the displacement of the particle in the sound wave at a particular distance from the sound at the instant. Which statement about the motion of the particle is correct? The particle is moving away from the source? No. The y particle is moving towards the source because the displacement is towards the left. Left displacement means ये equilibrium position है, ये आपकी source है, particles की displacement left की तरफ है, source की तरफ है, equilibrium position से away है. The particle is moving towards the source, that correct. The particle is moving upwards, no, ये तो भाई आपकी sound wave है. It has rarefactions and compressions. The particles are moving parallel to the propagation of the wave. They're not moving upwards and downwards. ये सिर्फ आपको दिखाने के लिए left right दिखाने के लिए ऊपर नीचे बनाया हुआ है. It just looks like a transverse wave, but in reality it's a longitudinal wave. अच्छा, the particle is moving downwards. Particles are not moving upwards or downwards. They're moving left and right. Two polarizing filters are placed next to each other so that their planes are parallel. Okay, so that their planes are parallel. The first polarizing filter has its transmission axis at an angle of 50 degrees to the vertical. The second polarizing filter has its transmission axis at an angle of 20 degrees to the vertical. The angle between the transmission axis is 30 degrees, the relative angle. The beam of vertically polarized light of intensity this is incident normally on the first polarizing filter. What is the intensity of the light that is transmitted from this second polarizing filter? Okay, so the first is I transmitted equals to I naught, which is 8 cos square theta. For the first filter I'm calculating, it's 50. So the I transmitted for the first filter that's going to pass from the first filter is going to be 8 cos 50 square. That is 3.3. Now this 3.3 has to pass through the second polarizing filter. So I transmitted equals to 3.3 cos square. Over here, be careful. You have to take the angle, the relative angle between the first and the second filter. First is 50, second is 20. So the relative angle is 30. So over here you have to take 30. So 3.3 cos 30 square. You get 2.475. 2.475, which is option B. Got it? You have to take the relative angle between the two filters. A dolphin is swimming at a speed of 16 meters per second directly towards a stationary underwater microphone. The dolphin emits frequency of this, and the speed of sound is this. The frequency of sound detected by the microphone, obviously it's going to be greater than 122 because the dolphin is moving towards, so we cross this, and 121 is going to be crossed. Obviously it cannot be less. 1330 is hertz, so 123 it becomes 1.3 kilohertz. No, it's gonna be this. Just by looking you can tell, like, because the dolphin is swimming towards, and when you move towards an object the frequency increases. You can use the Doppler effect formula. If you don't even know the formula, this question is so easy, it can just be solved by looking at it. Ashaji, the next question states that a student carries a double slit experiment using a laser emitting a red light of wavelength 680 nanometers. The light is incident normally on a double slit. The diagram shows part of the pattern of bright fringes visible on a screen. The distance across the 5 bright fringes is measured at 34 millimeter. What is the slit separation? Acha ji, so x equals to lambda d upon a. Your x is your fringe distance, so between 1, 2, 3, 4. 4 fringes is 34 millimeters, so one fringe is going to be 34 upon 4 into 10 raised to power negative 3 meters. अच्छा, ये आ गई हमारी x ये आ गई, तो a equals to lambda आएगा 680 nanometers, so into 10 raised to power negative 9 times d, which is 2.4 meters upon 34 upon 4 into 10 raised to power negative 3. Put this entire thing into calculator to get the value of a. 680 into 10 raised to power negative 9 times 2.4 upon 34 upon 4 into 10 raised to power negative 3. And what I get is 1.92 into 10 raised to power negative 4, which is option C. The diagram shows the stationary wave on a stretched spring at one instant in time. Two particles P and Q are shown. So this is a stationary wave, remember. A P is an antinode. In stationary wave, particles move, but they don't change their amplitudes. That remain the same. Okay, which statement about the vibrations of P and Q is correct? They have different frequencies. No, they're moving with the same frequency. They have same amplitudes. No, they have different amplitudes, and that amplitudes are not going to change. They have different period. No, they have the same period, because the amount of time it's going to take to complete one wave is going to remain the same. They're always in phase. Yes, that's correct, because P and Q are between two adjacent nodes, and all particles between two adjacent nodes are in phase. They move upwards and downwards and rightwards and leftwards, and wherever they move together. And the particles, a particle here and here, they are 180 degree out of phase. Like this particle and this particle are going to be 180 degree out of phase. Any particle over here is going to be out of phase with any particle over here, but any particle between these purple lines is going to be in phase with the particle in the purple line. Ashaji, green laser light passes through a diffraction grating and forms an interference pattern. The diffraction grating contains 400 lines per mm. Acha, there are 400 lines per mm. The wavelength of the laser light is 550 nanometer. What is the highest order diffraction? Okay, so first you need to realize, if there are 400 lines per mm per meter, how many lines are there going to be? You multiply this by 1000. So they're going to be 4 into 10 raised to power 1, 2, 3, 4, 5 into 10 raised to power 5 lines per meter. And that's the value of 1 upon n, which is 4 into 10 raised to power 5 sine theta. Since they're saying the wavelength of the laser light is this, what is the highest order? Highest order means that you take sine theta as 90 and then you get the answer, and then you round down your answer. You don't round up the answer, you round down the answer. So equals to n lambda. N you don't know, you have to find. Lambda is 550 into 10 raised to power negative 9. Okay, so 1 upon 4 into 10 raised to power 5 sine 90. Sine 90, even if you don't write, because I think it's equal to 1, but still let's do it. And then you divide this entire thing by 550 into 10 raised to power negative 9. What do you get? You get 4.5, but you round it down to 4, so they're gonna be the highest order is gonna be 4, right? It means, मैं आपको दिखाती हूँ इसका क्या मतलब है. इसका मतलब है कि on your diffraction grading you're gonna have 4 lines, like this is gonna be a center line, then they're gonna be 1 2 3 4 lines like this, and 1 2 3 4 lines like this. There's a potential difference V across a resistor of resistance R. The current is I. Which equation gives the power dissipated in the resistor? This is incorrect equation because P equals to VI. This is also incorrect. You know it's V square upon R. This is also incorrect. This equation is correct. P equals to V square upon R. I guess that's theory we've studied. What is the possible charge on a particle? For this, you always need to remember one thing, that charge is quantized. Charge is quantized. That means it has a fixed value. So divide all of these values by 1.6 into 10 raised to power negative 19 and check what you get. So first value, which is 6.40, you should get a whole number for the charge, like 2 or something like that. So 6.40 into 10, 6.40 into 10 raised to power negative 20 upon 1.6 into 10 raised to power negative 19. This gives me 0.4. So अच्छा, अब सबका निकाल के फिर I'll tell you what to do. For the second value, you put it 4 into 10 raised to power negative 19. This gives me 2.5. Next value I put now, which is 1.12 into 10 raised to power negative 18. I get 7. So that is my answer. I was looking for an answer in whole number because charge is quantized. That means it cannot be in decimals. It cannot be in decimals. It comes in fixed packets. Like if you're buying oranges, you cannot get a half orange. Either you can get 1 orange or 2 orange or 3 orange. That's how you get charge. You can get charge in packets. You cannot get 3 oranges and 1 scoop of an orange. You get full oranges. That's how you get full charges in packet form. So that's why the answer of a charge should come in a whole number. The graph shows possible IV characteristics for a filament lamp and for a semiconductor diode. Which IV graph is for a lamp? You know lamp is gonna bend, so P is for the lamp, and for a diode, I guess that's so simple. This R is for a diode because diode allows current. After a certain point, it's gonna allow. If it's forward bias, if it's backward or negative bias, it's not gonna allow. So it's option number A. So over here we have a circuit and we have to find the resistance of the resistor P. Remember Kirchhoff's voltage laws we're gonna use, so we're gonna create loops over here. The first loop we're gonna create is this way, and the second loop that we're gonna create is for the current in this P resistor. How can I figure out the current? Look, I know 3 ampere is flowing here. Here I have 3 ampere. And my 2 ampere is flowing upwards like this. So over here I have 2 amperes. So you know that the sum of currents that is entering this junction, which is 3 amperes and 2 amperes, equal to the sum of the current that's going to leave the junction, which is 5 amperes. So 5 ampere is going to flow through my resistor P. And now when this 5 ampere is going to flow here, out of that 5 ampere, 2 ampere is going to go back here and at this junction 3 ampere is going to go back here, and then 3 ampere is going to flow. Now using my junction, I know that the EMF drop and gain and everything is going to add up to 0. So firstly over here, when I move from a negative terminal of the battery to the positive terminal, I get a gain. This is my loop. This is the direction of my loop. So I'm moving in my loop. So when I move from negative to positive terminal, I get a gain of voltage, that is plus 9. Okay. And then when I move from across a resistor, this resistor P, I get a drop in voltage because my resistor is going to use up my voltage. When my direction of current is down and my loop is also downwards, then I get a drop in voltage. So my drop in voltage is going to be negative 5, which is my current, times P, which is my resistance. So negative 5P, because you know that voltage equals to IR. I is the current, which is 5, and R equals to P, which is the resistance. And then I move across my battery from the positive terminal to the negative terminal. Whenever I move from positive to negative, my voltage gets used up. So negative 1, and then I move across the 2 ohm resistor in the direction of the current, and the current is 3 amperes multiplied by 2 ohms give me 6 volts. So there's going to be a drop of 6 volts over here. So minus 6 volts. And when I get back to my battery over here, the sum of all this should be equal to 0. That is what my Kirchhoff's second law, which is the Kirchhoff's voltage law, KVL, states. Okay? All the drops and gains in a loop add up to 0. So now I have to figure out the value of P from here. So plus 9 minus 5P minus 7 equals to 0, plus 2 minus 5P equals to 0, 2 equals to 5P, 2 upon 5 equals to P, P equals to 0.4 ohms. Okay, so 0.4 ohms. Did you get it? How did I solve it? I simply used KVL, Kirchhoff's voltage law. And you can see some videos on YouTube about it, and you're going to better understand that how do we do it. Let me give you a little introduction of this law. Whenever I move from positive to negative, like this, so this is the direction, I'm moving from positive to negative, so there is going to be a drop in my voltage. And whenever I move from negative to positive in my loop, there is a gain in my voltage. Okay, so over here, look, I moved from negative to positive, so there was a gain of positive 9 in my voltage. And for resistors, whenever this is my resistor, okay, this is my resistor, whenever my loop, this is the direction of my loop and this is the direction of my current, this is positive, this is negative. So whenever I move from high potential to low potential, there is always going to be a drop in my voltage. And now this is my resistor, and I move, this is positive, this is negative, I move in this direction from negative to positive. So then there is going to be a gain in my voltage. Okay? The diagram shows this circuit with the battery connected to a resistor R. The battery has an internal resistor represented by resistor R. Okay, I have internal resistor, then I have capital R. A second resistor identical to R is connected in parallel with R. So I add a resistor identical to it in parallel with it. Whenever I add anything in parallel, what happens to the total resistance? It drops. So current shown on the ammeter is going to increase because the resistance is going to drop. And PD across R. अब आप खुद देख लें, जब इसके across जो resistance है वो drop हो जाएगी. आपको पता है कि resistance का जो relationship है with the voltage from the battery, it's a direct relation. The more resistance you have, the more voltage you get from the battery. So if the resistance is dropping over here, इसका मतलब है इसको कम voltage मिलेगी, इसका मतलब है इस R को ज़्यादा voltage मिलेगी. समझ आई? So PD across R is gonna increase. Done? two identical wires X and Y, each of length L and radius R, are connected in parallel as shown. So they're connected in parallel. The total resistance of this combination is R1. Wire X is replaced with a wire of the same material and length L with a radius 2R. Okay, the total resistance of the new combination, what do you think? What's going to happen to the resistance? Firstly, is it going to increase or is it going to decrease? It's going to decrease, because what you're doing, you're increasing the area, and you know that resistance equals to rho L upon A. Yeah, that's the formula for resistance. So increasing the area decreases the resistance. So if the resistance is decreasing, that means the denominator is decreasing. If the denominator is less, it should be less. So या तो ये होएगा, सी होएगा या डी होएगा, जहाँ पे डिनोमिनेटर लेस है. ए और बी को आप क्रॉस कर दें. अब हमें पता लगाना है कि सी होएगा या डी होएगा. Okay, so now we have to see that when we make it 2R, because area equals to pi r square, area increases by 4. So if the area is going to increase by 4, the resistance R2 is going to decrease by 4. Okay, so if the resistance is going to decrease by 4, तो अब हम क्या करेंगे कि अब हम अपनी X वाली वायर का रेजिस्टेंस जो है वो पहले R था, अब R/4 हो गया. So now what do we do? It's 4 times less. So इस पूरे कॉम्बिनेशन का रेजिस्टेंस गिर जाएगा. अब हमें एक्सप्रेशंस जनरेट करने पड़ेंगे, वरना उनके बगैर 5/2 और 3/2 तो नहीं होने वाला. एक सेकेंड ज़रा ये देखें. फर्स्ट अगर हम कंसिडर कर लेते हैं, पहले जो था वो इसका था 1 और इसका भी था 1, ठीक है. सो 2 कर लेते हैं. 2 होएगा, इसका भी 2 होएगा. सो 1/2 प्लस 1/2 का इन्वर्स, राइट. चलें, अब क्या आंसर आ रहा है? 1/2 प्लस 1/2 का इन्वर्स ले लेते हैं. हमारा आंसर आ रहा है 1 अपॉन. अब आपने लेना है, ये 4 दफ़ा गिर चुकी है, ये 2 जो है इसको डिवाइड करते हैं ज़रा 4 से. 2 को डिवाइड किया 4 से तो आंसर आया 0.5. तो अब आप ले 1/0.5 प्लस 1/2 का इन्वर्स. 1/0.5 प्लस 1/2 का इन्वर्स. अब आंसर आ रहा है 0.4. सो 1/0.4 कितना होता है? 1/0.4 5/2. गॉट इट. सो इट्स गोना बी ऑप्शन नंबर डी. आपने सिंपली करना था कि इसकी रेजिस्टेंस को 4 टाइम्स गिराना था. पहले मैंने 2 ले ली, फिर मैंने 4 टाइम्स उसको गिरा के 0.5 ले लिया, और फिर पहले मैंने 2 से उसका कॉम्बिनेशन का रेजिस्टेंस निकाला, फिर 0.5 से निकाला, एंड आई गॉट 5/2. Okay, the diagram shows the currents in part of an electric circuit. The resistors are identical. Which equation is not correct? कौन सी नहीं correct? Okay, अब हमें पता है I1 equals to I2 plus I4 plus I5. I1 equals to I2 plus I4 plus I5 बिल्कुल करेक्ट है, बिकॉज देखिए I1 यहाँ से आ रहा है, I2 में डिवाइड हो रहा है और I3 में डिवाइड हो रहा है. अब आप कहेंगे I1 equals to I2 plus I3, बट I3 आगे I4 और I5 में डिवाइड हो रहा है, तो I1 equals to I2 plus I4 plus I5 करेक्ट होएगा. I2 equals to I1 minus I3. I2 equals to I1 minus I3. सही बात है बिल्कुल, बिकॉज अगर आप I1 में से I3 को निकाल देंगे तो I2 आ जाएगा ना, बिकॉज इन दोनों को ऐड करके ये आ रहा है, तो इसमें से इसको माइनस करके ये आ जाएगा. तो सिंपल मैथ्स है, वेरी इजी. बस जंक्शन पे करंट ने डिवाइड होना है. I2 equals to I3 plus I4 plus I5. That is incorrect. I2 equals to I1 minus I3 या फिर I2 equals to I1 minus I4 plus minus I5. ये इक्वेशन बन सकती है या ये इक्वेशन सही है, ये वाली गलत है. इन तीनों को ऐड करके, इन दोनों को ऐड करके ये आता है, तो इन तीनों को ऐड करके ये तो नहीं आने वाला. I4 equals to I3 minus I5. I4 equals to I3 minus I5. करेक्ट बिकॉज इसमें से इसको माइनस करके ये आ जाएगा. सिंपल. Okay. The diagram shows a sequence of radioactive decays involving 3 alpha particles and a beta particle. What is nuclide T? Okay. No worries. Firstly, alpha decay में we have to decrease the proton number by 2, so it becomes 91, and decrease the nucleon number by 4, so 237 minus 4. 237 minus 4, 233. 233. A beta negative decay में this remains 233, but this becomes, it increases by 1, so it becomes 92. Now in alpha decay, this again decreases by 4 and this decreases by 2. So 233 minus 4, 229. 229, and 92 minus 2 is going to give me 90. And then in alpha decay, 229 again decreases by 4 and becomes 225, and this decreases by 2. And it becomes 88. So 88 and 225. Option A. Got it? Alpha decay means decrease the nucleon number by or the mass number by 4 and the proton number by 5. Okay. A number of electrons in a neutral atom of an isotope of plutonium, this is changed to produce a charged atom of W. So initially I know that my proton number and my electron number is going to be 94, but now it is changed. It can increase or it can decrease. W has an overall charge of this plus this. That means I lost an electron because this is the charge of one electron, but it's a positive. That means electron is lost. How many protons, neutrons, and electrons are in W? Protons never change. Electron is going to be one less, and I don't know about the neutron, so A option ban gayi. समझ आई? Which particle is a lepton? A lepton is a fundamental particle, so it's a quark. Leptons positron होएगा. Leptons में आते थे electrons, protons, neutrinos और antineutrinos, तो positron. This is all learning. So I think it's gonna be a positron, and with that we are done. Mesons and baryons and hadrons and whatever, सारा आप याद कर लेना. Done.